So before we jump into the objective and having you write things down and whatever, could you please tell me the term for the answer to an addition problem? Think about it, don't say it. The term for the answer to an addition problem. Turn and tell your group, go. Nice. Oh, that was very calm and quiet and collected. I love it. So the answer to an addition problem is the sum. Beautiful. Okay. Now we're gonna do subtraction. So think about it. Think back to your math basics. What is the term for the answer to a subtraction problem? Think about it. Tell your group, go. Oh, you guys are close. 5, 4, 3, 2, 1, 0, 0. It is difference, my friends. Difference. Okay? For a subtraction problem is difference. Okay, so when we say 5 minus 3, the difference between 5 and 3 is 2, right? The difference. So what's the gap between the two, right? It's the difference. Okay? Again, please put away things that you're going to be distracted by. Okay, great. Kind of running out of room here. So now we're going to do multiplication. You guys should know this one. Class, the answer to a multiplication problem, go. Product. Awesome. Product. Okay. And then division, which we won't really be working a whole lot with today, but it's important to remember. Division. Okay. Think about it. Turn and tell your group, go. The answer to a division problem. Starts with a Q. Equation. Quotient. Thank you. It is quotient.
The answer of it is called denominator. Oh, why would I say denominator?
You're not wrong. All right. Cool, my friends. So these are going to be very important for the lesson today. We are going to be using this vocab a lot, but mostly my friends over here, sum and difference and product. Not as much quotient, but who knows? It might pop up. Right? Donnie.
We get to do most of my favorite. I like adding and multiplying.
Good.
The numbers just go up.
Nice. Love it. So, Lily, is that how we sit in a picture class? Thank you. Okay. Please get out your notebook and a pencil, and I want you to write the lesson number, the date, and you're going to write these vocab words right here. Okay. However, it's going to make the most sense to you. If you just want to put the symbol in the word, that's fine. But bottom line, you need to know that this is for addition, this is for subtraction, this is multiplication, this is division. I'm going to give you 1 minute. Shouldn't take you more than a minute. Yeah, 1 minute. Go. Okay, keep the voices off. Just brain power. Okay, about 15 more seconds. All right, everybody get it? No, why do you write so slow?
Because we're trying to write good.
Well, that's good.
If I write normal, you can't read it.
Doesn't matter if I can read it. If you can read it, that's fine.
I can't read it.
Oh, okay.
You're like, what is this? It's like the words are like together, but it's not written.
Egyptian hieroglyphics. Okay, finish up. Once you get it, can you put your pencil down so I know you're ready to move on?
Yeah.
Here. Keep it tight. Okay, I am moving on. We take too much time with this, okay? But everybody get this concept, yeah?
Yes.
So our objective for today's lesson is we're going to write and interpret. So we're going to physically write, and we're going to interpret, meaning we're going to understand, okay? Numerical expressions. Numerical just means numbers, okay? When you see numerical, I want you to think standard form, okay? When you see the word numerical, I want you to think standard form, okay? So just plain old numbers. So we're going to write and interpret numerical expressions, which are just sentences, right? And compare expressions using a visual model. So we're going to be using kind of like a tape diagram today, but it's a little different, okay? So you're going to kind of compare them, saying, oh, this one's bigger, this one's smaller. So our friends greater than, less than, or equal to are also going to come into play today, okay? Danny.
Fun fact, numerical also means like numeral, as in another word for number.
Number, yep. Mm-hmm.
Roman numeral.
All right, so does everybody understand what we're doing today?
Yes.
Okay, awesome. Moving on. Maybe. Cool. All right, you don't need anything yet. You are just going to look up here. So actually go ahead and just close your notebook. Maybe put your pencil inside so that way you're not tempted to use it. And that way you don't lose a place in your notebook as well. Okay? So looking up here. Brooks, yeah? Are you stretching?
Oh, I'm putting my hands up so I'm not touching them.
Oh, okay. Well, your arm's going to get tired, so I would maybe put it down, okay?
She's stretching.
Okay, so we're going to talk about what expression describes the total value of 3 equal units. So basically what this is saying, okay, is 5 3 times, okay? And it's actually kind of cool because 4th grade is doing something very similar right now. You guys remember when we were saying, oh, the length is 3 times as long as the width, right? Like that sort of thing. They're doing that right now. So it's kind of cool how it connects. But 5, what this is saying right here is that this box equals 5, okay? Since they all look very similar, we can assume that this is also 5 and this is also 5, okay? So there are a number of ways that we can say this, but we can say 3 times 5, right? 3 copies of 5. Does everybody get that?
Yes.
That's pretty straightforward. So then when we get to things like this, okay, you guys remember that when we don't know the value of something, oftentimes in math they'll use a letter. The older you get, the more letters they use. Okay, it's called algebra.
Yeah.
It's pretty fun, but it's a bit confusing. But you guys are going to do very, oops, I'm talking. You guys are going to do very basic forms of algebra in this grade, in 5th grade, okay? So this is algebra right here. When we have a letter instead of a number, it just means we don't know what the value is. This could be 3, this could be 3,000. We don't know, right?
Yeah.
Bottom line, this equals A, right? And so since these are all similar, we can assume that since this is A, this is also A, this is also A, right? So for our numerical expression, we can write 3 times A, okay? It's the same thing. It's the same thing. Even though we don't know the value, we can write 3 times A, and we know that it's going to be A 3 times, okay? Okay, Lily, Brady, Olivia.
So when I was in 3rd grade at my old school, we did this. But we would do like Q divided by 5 equals something. But it was actually really helpful because you would do like equals like 17 or something. Like that's not like 17. And then you'd like do whatever like times or divided by 5 equal like 17 or whatever.
Yeah, and you guys did that a lot last year too with area and perimeter. Like, oh, the area equals this. One of the side lengths is this. So the other side length has to be this.
Sorry for the interruption.
That's
Just a clarification. No football at lunch. Period.
Okay.
At least for a week. That is through next Wednesday.
Okay.
I've taken 1 football away, this grade level, 1 at the 3rd grade level, and it's none until we have some settling down, not pushy shoving, and getting in line after recess so that you come in. So, no football. Find something else. And then it's not baseball because we don't bring baseballs here. Question, Emma.
Do you mean just at lunch, no football? Or no
Or like
football?
Recess.
Just recess in general.
Recess in general.
Okay.
Period. Yes, sir.
Can we play kickball?
Kickball is usually pretty calm.
Yeah,
I would say
yeah,
kickball's fine.
Yeah, yeah.
Yeah.
I have no problem with kickball. Right now,
Yeah.
you know, you may get it so that everything's all aggressive and everything. You may be playing with jacks and marbles. I don't know. But I've seen marbles get out of hand too.
Yeah.
Yes, sir.
Do we play wiffle ball?
What ball?
Wiffle ball. I don't think you can bring those, though, can you?
Yeah, but we brought them earlier before, but we never.
Yeah, I would
Like,
say
we
no.
just
I would say no on that one. Just let's stick to kickball or like gaga ball, tag, swinging. So four square, like
Yeah, this
basketball. Yeah.
not lining up when you're asked to by the person on duty and going after a football is just, you all line up, you'll get your ball back, you listen to the teacher and get it done. But there's also some ground action that's getting a little rough and tired of it.
Yeah. Okay.
As I explained to these guys, I referee football.
Yeah.
In the high school level and have at college too.
Yeah.
So,
He knows what's up.
it's done for now.
Okay.
Work yourself back into it, be good at recess, and we'll get it back hopefully next Thursday,
Yeah. So through next Wednesday.
through next Wednesday. Yes, ma'am.
What's going on? Just a question.
He said, yeah. He said no football for a week.
No sports.
So,
as in
No
general?
football.
Good job. Thank you.
Okay.
See
Thank
ya.
you. Thank you. All right. Cool. We're gonna go back to math. Okay. So, Brady, do you remember your question?
Oh.
It's okay.
Yeah, I remember doing algebra in second grade. We did like
Mhm.
it wasn't like big, but it was like sometimes it would be like something times something, and it'd be like 3 times A times B.
Yeah. Cool. Kind of like what Lily was saying. Yeah.
Mhm.
Awesome. So you guys are familiar with it to some extent. But just know, like when you get into middle school and high school, it's like
It's like
Oh.
52 divided by 16 divided
By
by A divided by B.
Z.
divided by
Yeah. It's crazy. Okay. Olivia.
Does it have to be the amount of boxes times whatever number?
Good question. For today, yeah. So you guys will be representing numerical expressions with a tape diagram like this. So, I will get to that in a little bit, but yeah, that's a great question. So, yeah, Nana?
Yeah, like my brother's in like high school, like
Mhm.
last year.
Mhm.
I think he's like doing like that, but like way much harder. Like,
Yeah.
it gets harder and harder.
It does. But that's why we do foundations now, like in second or like third grade, like Lily was talking about, right? Like we do foundations of it so that hopefully when you get to that level, it's not too hard, right? So yeah, is it okay if we move on? Is that right? Okay, so I want to kind of flesh this out a little bit too. Different ways that we can talk about this. So yes, it's also 3 times 5 or 3 times A, right? But we can say also like in words, right? 3 times 5, okay? Or even more so, we can say like in word form, 3 times 5, right? So this is a lot of what we'll work with today. It will get a little more complicated. We can also say like 3 A's, right? 3 A's or 3 5s, right? 3 copies of 5. There's so many ways that we can say that. And so that's a lot of what we'll work with today, okay? So I'm going to go ahead and do this one, and then you guys will join me on the next one, okay? So 3 times the sum of 26 and 4. Now this is where that language is going to come in handy, right? This is where it's going to be really important. So 3 times the sum of 26 and 4. So in order to show that on a tape diagram, right, I know it's going to be 3 times something, okay? 3 times something, so 3 copies of something, right? 26 and 4. So 3 times the sum of 26 and 4. So 26 and 4, 26 and 4, 26 and 4, right? The sum of this. And it's 3 times, right? Does everybody see like what we're doing here? Today is very literal. Like if it says 3 times the sum of this thing, that's exactly what it is. The sum of this thing 3 times, right? So then I would go through and I can solve that, okay? So 26 plus 4 is going to give me 30, okay? So the sum of 26 and 4 is going to equal 30. So that means this box is 30, this box is 30, this box is 30, okay? And it's 3 times that. And then I could go further and solve that, right? So all together, 3 times the sum of 26 and 4 is going to give me 90. So my answer is 90, okay? And that's pretty much what we're doing today. And then with our expression, so it's written in words, okay? And now it wants me to write it in some form of numerical expression, okay? So there can be multiple ways that you can write this, and you'll see it a bunch of different ways. But I personally like to use the distributive property, okay? So this is what this looks like. So 3 times the sum of 26 and 4. And this might be familiar to you from area and perimeter. Remember we did perimeter was 2 times the sum of length and width, right? So that might be somewhat familiar. But this is the distributive property. Anytime we see a number next to another number, it means multiplication. So you also could just put a multiplication symbol there, and that would be fine. However, this is the important bit. Because of order of operations, we have to do what's in the parentheses first, okay? So like it doesn't exactly apply to like addition and multiplication, but when we get to subtraction and division, the order does matter. So we would need to add this first. We would need to find the sum first before we multiply it by 3, okay? So yeah, so this is one way we can write it. We also could write it like backwards if you wanted. So 26 and 4 times 3, that would be totally fine, okay? And then we find the value of the expression, which I already kind of showed you how to do that, okay? Okay, Maddie, you may go. Henry, did you have a question? No? Okay. Any questions about this? Olivia.
Do you have to solve like 3 times 30 or?
So that's what this part would be, find the value of the expression. That's like solve the expression. So if I were to do it, I mean, I kind of did it up here like in my head, but if I were to do it with the expression here, so 3 times, and then the sum of 26 and 4 is 30, so then 3 times 30 would equal 90. Okay? All right. I would like you to do this one with your group in your notebook. Okay, so this is like the example you're going to write, and you're going to do it together. So you're going to do the tape diagram, the numerical expression. I'm going to put numerical. Hold on, don't start. You're going to do all 3 parts. So tape diagram, numerical expression, and then solve it, okay? So number 3 is solve. Does everybody know what they're doing with their group? Okay, it's very helpful to read it out loud, and then that can tell you exactly what you're going to write and draw and that sort of thing, okay? I'm going to give you guys like 3 minutes, okay? 3 minutes. Ready, go.
Aren't we supposed to be working as a group, guys?
Yeah, you're doing it together. You're doing it as a group.
So tape diagram, put 6 boxes. Draw 5 lines to make 6 boxes. Then you have to divide. Then you subtract 60 times 50. No, 60 minus 60 times 51. 60 minus 51, then that times 6. Yeah, that's what I just said. 60 minus 51. So 6 times 9 is 6 times 9 is so it should be 9. So there should be 9 in each group.
How are you guys doing? That's okay. If it's helpful, you can start with the expression first, like the number part first, and that might help with the tape diagram. But so 60 is the difference.
It's like find the value.
So the difference is a keyword for what? For what?
9. Then 6
Wrote it down.
then 4.
Fraction, yeah. Okay. So you know that you're going to have to find the difference between 60 and 51. That's step 1, right? So I would write that in parentheses. Right, 60 minus 51. And then it says 6 times that, right? So then it would just be times 6.
Oh, yeah.
Does that help solve it? No, yeah. So the difference, the difference between 60 and 51. So you have to find the difference. That's okay. Yeah. So find the difference first between these two, and then multiply that by 6. Okay. Yes.
I got tired. My legs.
Okay, you got about a minute, my friends. 1 minute.
I just put in and space and the heart. So 3 is 54. We think we got it.
Okay.
You're whittling.
Okay, next we do that. It's not very common that we need scissors during math, so we can take the ruler.
Cut something then.
Yeah, unless we're making models or something. Okay, by the silence, it seems like most of you are done. Is that true?
I feel like it'd be the opposite, loud. Yeah, loud is when we're
Maybe.
silence is when we're not. Well, then we'd be at 2s, so
Well, yeah, but then once you're kind of done
you get loud.
working together,
Yeah,
then,
it seems like we get loud. We're sorry, Miss Whit, that we get very loud.
would you? Alright, we're gonna move on. 5, 4, 3, 2, 1. Alright, Olivia, thank you for being voluntold to do it on the board. You may show us what you got. Good.
C minus 51 is 9. Yeah.
Can you say one more time how you got 9?
60 minus 51 is 9.
Perfect.
And then 6
Awesome.
60 minus 51 is 9. So 66 times 5.
Awesome. Beautiful. Thank you. Give Olivia a round of applause. That was awesome. All right. So, 5, 4, 3, 2, 1, 0. Okay. So, for the tape diagram, she saw, or her group saw, they all kind of did it together, right? And I'm sure you guys were on the right track too. But 6 times the difference between 60 and 51. Pro tip, my friends. Pro tip. If there's any sum or difference, if you see the words sum or difference, okay, odds are you got to do that first before you multiply, okay? So just keep that in mind. So 6 times the difference between 60 and 51. The difference between 60 and 51 is 9, as Olivia said. So 6 times, there's 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, okay? So questions on the tape diagram part. Okay. Cool. And then the numerical expression, you're basically writing exactly what you hear, right? So 6 times the difference between 60 and 51, right? Since we have to do the subtraction first, that's going to go in the parentheses, right? 60 minus 51. And then after that, it's 6 times. So 6 times the difference of 60 and 51. Henry, question?
I was just gonna say on the numerical,
Mhm.
whenever you see the, I forgot what they're called, the
Parentheses?
parentheses around any thing, you always do that first.
Yes, definitely. So anytime you see these little guys right here, parentheses, that has to go first. And that's true for all math everywhere, okay? Even when you get into high school or college, anytime you see something in parentheses, that has to go first, okay? Olivia?
When we started doing that in 8th grade, they taught us to do
Oh, cute. I love that. Yeah, for sure. For sure. Do be first. Yeah, love it. And then 3, my friends, finding the value of the expression. So Olivia went through and solved it. She knew that the difference between 60 and 51 was 9, and it was 6 times that. So 6 times 9 equals 54. So the final answer for all this is 54. Okay? Any questions on this? Okay. I'm going to just kind of like breeze through the next few. So if you could just be with me for like 10 more minutes, and then we will be good. Okay? So, you guys are doing great. So, we're not really going to solve this one as much, but I just want you to kind of look up here. This is another way that you're going to see these together. So, it says sum of 2 12s and 4 3s. Okay? Sum of 2 12s and 4 3s. So, 2 12s. Right? And you don't have to write this. I'm sorry, this is the expression. Okay? 2 12s, sum of 4 3s. Okay? Alright, do you guys see that? Okay. So if we were to do a tape diagram for that, sorry, I kind of did it backwards. Personally, my brain works better with numbers than tape diagram, but if yours works the other way, that's totally fine. So we would do 2 12s and 4 3s. Okay? The sum of 2 12s, 4 3s. And then I know I spoke too soon. Last problem I said, anytime you see sum or difference, do that first. However, can we add anything together right now? No. But they're in parentheses, right? So parentheses first. 2 times 12 is 24. 4 times 3 is 12. So 24 plus 12 is going to give me 36. Okay? So yeah. Henry, can you go when Jackson gets back? Any questions on this one? Okay, so you will see it like this, like 2 12s. Just think of that as 2 copies of 12. 4 3s. Okay, 4 copies of 3. Okay? And then here, you're also on your homework, you're going to be doing like the opposite. So it's going to give you the expression, and you have to write it in words. Okay? And there's a couple different ways you can do that. So you can say 8 times the difference. And yes, you have to write it out like this. The numbers, you can just write as numbers. That's fine. Okay? So 8 times the difference between, or you can even say of 43 and 13. Okay? So when it says write it in word form, it's exactly what you're doing. 8 times the difference of 43 and 13. So in your notebook right now, I do want you to write this. So the expression, and then write the words underneath. So you know that that's what it looks like. When we have an expression, we write the words underneath. So go ahead and write this in your notebook right now. Yeah.
I ran out of room.
Oh, yeah, keep on the back or something like that. Problem solved. You don't have to write these, bless you. I'm just putting them up there, so once you're done writing, you can kind of think to yourself, oh, how would I write that? No. You don't have to write them. I just put them up there so when you're done writing, you could look at that and say, like, wonder, oh, how would I write that? Don't write. Okay. You can if you want, but. Oh, you guys didn't hear what I just said. You don't have to write these. I just put them up there. Why? So you could.
What you should write.
Good. Think about how you would maybe write them. Okay. Questions? Yes, but it's cool. It's cool to be a nerd. All right. 5, 4. Why does this keep happening? 3, 2, 1, 0. All right. Did everybody get this one down?
Yes.
Yeah. Okay. Olivia. Mm-hmm. Good question. Okay, so we have moved on. My friends, I have called you to be quiet and you're listening now. Olivia had a question. Olivia said, for these two, like, do they have to be in the exact order that it's written there? Not at all. So for this one, it says, you know, the sum of 16 and 9 times 4, but you could totally write 4 times the sum of 16 and 9. That's totally fine. You could also say the sum of 16 and 9 4 times, right? This one, my friends, you could say 320, or the sum of 3 20s and 3 5s, right? Or 5 3s, like, you know, get creative with it. But bottom line, it's very important, okay? This part is very important. You guys gotta hear this, okay? For like things like this, I do not want you to say 16 plus 9 times 4, okay? Because what that can show me is, okay, would I get the same answer if I did that?
No.
No, right? So that's why it's important to use the same language. So that's why we have to say the sum of 16 and 9 times 4, right? Because we would get a different answer if we did it that way, right? So that's why it's important. That's why the language part is important. So please be super careful when you're writing these expressions and stuff, okay? All right, last but not least, and I'm sticking to my time. This is great. You guys should be proud of me. So thank you. All right, so this is kind of the last thing you'll do on your homework. So it says you're going to compare each expression in word form and numerical form. So it gives you 2 different expressions that are in, one of them is in numerical form, one of them is in word form, right? So it says draw a tape diagram and then compare. So 9 times 13, oops, just simply means 1, 2, 5, 6, 7, 8. Okay? 9 times 13, right, is just 13, 13, 13. Check it out. Check it out. You can put, let's see if I can make this small. Hello. There we go. Oh, that's too small. This way. Okay, anyway.
That's a cute little
To save time and energy, okay, you can put dot, 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 okay, it's called an ellipses, okay, so you don't have to write 13, 13, 13, 13, 13, 13, 13, right, and save time, and just put 13 at the end, right, so this is 13 times 9, okay, everybody see what I'm getting at? And then over here, we have 8 13s. I also need to show it in a tape diagram. So 1, 2, 3, 4, 5, 6, 7. So again, 13, 13, 13, dot, 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 13. Okay? So I see 1, 2, 3, 4, 5, 6, 7, 8 13s. But over here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 13s. So which one is bigger, my friends, left or right?
Left.
Left. So if I had one of those circle thingies in between them, I would put greater than. Okay? So that's something also that you'll be doing on your homework. Drew and then Donnie.
You put like 13 and then dot, 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 and then 13 at the end. Get on the
I would maybe give like 2 or 3 and then do the dot, dot, dot. Okay? Donnie?
A little bit off topic. Can you bring back your baby eraser?
No.
He was so cute.
All right. Any other questions about this?
Baby eraser? No.
Okay. You may put your notebooks away. Okay. You're gonna do the problem set. Oops, hold on. That doesn't require voices, my friends. You just put it away. Anna, you're very distracted this morning. I just told everybody to put their notebooks away and you're playing with your stuff on your desk. Alright. So, we're gonna do the problem set just for 10 minutes. Wherever you get with the 10 minutes, we'll just stop there. We'll take a brain break and then we're gonna move on, okay?